Hi everyone, this is Adam Hops from the National Operations Center of Excellence. We're going to go ahead and get started today with this 10th of our SPaT Challenge webinar series. Before we get started, I just wanted to point everybody to the resources that are there at the bottom of the page. Again, the slides are available for download, and then there's quite a few links there on the left-hand side that Blaine Leonard and other presenters might discuss. So those are there and available to the left. I want to first thank Blaine Leonard of Utah DOT for leading the way on these webinars, the SPaT Challenge webinar series, as well as to all of our presenters who we'll hear about it in just a little bit for discussing their deployments and their good work around the SPaT Challenge. The NOCO YouTube channel there on the left has all the previous webinars, SPaT Challenge webinars, available. My colleague Nilu Parvanashtiani has also sliced up a lot of the presentations into smaller videos that are shareable for your colleagues and other folks in your organization who might be interested in the many different topics that have been covered throughout this webinar series. To hear more about upcoming SPaT Challenge and other NOCO webinars, please subscribe to our newsletter, follow us on Twitter and YouTube, and those will be available there. Without further ado, I'd like to turn it over to Blaine Leonard of Utah DOT to talk about the SPaT Challenge and about the resources that he's helped develop around the SPaT Challenge, and then to introduce our presenters. Blaine?
Morning, everyone, and good afternoon, and thanks, Adam, for that introduction. As Adam had indicated, all the lines are muted. We'd like you to ask questions. We'd like you to do it in the chat box, and we'll try to get to those towards the end. So we have some interesting presenters today from several different locations around the country. Here are the names of those folks who will be talking to us about some of their applications and deployments, and we'll introduce them more when we get closer to that. As you well know, if you're signed on to this webinar, the SPaT Challenge, which is about 2.5 years old now, is a challenge to all of us who were in the infrastructure and owner and operator segment, the state and local transportation agencies that own infrastructure. It's a challenge to us to deploy DSRC infrastructure that broadcasts SPaT and MAP in at least one corridor or network in our jurisdiction, maybe 20 intersections or so in each state by January 2020. So 20 and 50 by 20 is sort of the motto. And in 2.5 years, we've got about half the states with almost 40 locations. A number of states have multiple locations like ours. We have over 500 RSUs operating now in those locations that have completed their installation, and about 2,500 more planned around the country. So we're excited about that. We're making a lot of progress, and we're kind of moving forward with the challenge. If you're on this call and you're an agency or working with an agency that is moving towards the SPaT Challenge, intending to deploy, but you're not on that map we just showed you, we want to hear from you. We want to put you on the map. We want people to know that you're working on this. And so here's the on the SPaT Challenge website, which is at the National Operations Center of Excellence. Here's the link you can follow to give us your name, some contact information, where the SPaT Challenge will be deployed, a little information about it, and some timeline. And we would love to hear from you so we can get you up on the map and show additional progress around the country. This is our 10th webinar. We started webinars talking about the SPaT Challenge almost 11 months ago in March, early March of 2018. And we started with a webinar that talked just in general about the SPaT Challenge and how to plan for it. And then we looked at some design considerations, specific details about what you need to know in order to deploy, to help people get a handle on some of the issues they need to deal with, get some experience, learn from a few of those who were maybe a bit ahead of the game. We talked very specifically about building the map, and we had an entire webinar about a map creator tool that the Federal Highway Administration has available that you can download and use. And it's been actually upgraded and improved since that webinar early last year. We talked some more about design considerations, specifications, licensing of the roadside DSRC units. Then we started talking about deployments and started to learn from people who had deployed. And the 7th and 9th webinars were, in essence, largely about successful deployments. We find, as we look at the chat box and look at the kind of questions that you ask, that a lot of you are interested in lessons learned from real deployments. And so we've focused several of the webinars on that. We also sort of took the next step forward. We now have something called the Connected Fleet Challenge. After we deploy roadside infrastructure, a number of agencies have said, well, now what? And we kind of felt like the next thing to do would be to deploy some units in some vehicles that you own or a partner agency owns, and start learning how they communicate with each other. And that's kind of the next step. And so we focused a little bit on that in webinar number 8. If you look at this slide at the very bottom, there's an arrow that points to the link on the website that takes you to the recordings and the slide presentation material from all of those webinars. And a lot of people have gone into earlier webinars and have looked at those and reviewed them or seen them for the first time. And Adam mentioned that on each one of those webinars, they're even broken down by specific presenter and topic. So that's a great resource for you to go back and catch up on some of that earlier material. Just above that, there's an arrow that points to the SPaT challenge verification document. This is a document that we produced in conjunction with some folks from the OEM community to learn how we might validate our deployments. If we're deploying and broadcasting, how do we know we're broadcasting in a way that the cars will eventually be able to receive it, in a way that they're intending to receive it? So we focused this around an application that the automakers were building called the red light violation warning, and looked at the specific pieces of information that application needed and wrote this verification document around that. So any one of us can take this verification document, and then it describes a process for us looking at what we're broadcasting and make sure we're broadcasting it in an appropriate way that's useful for people. So I encourage you to download that and take a look at it. We also encourage you to tell us about your use of that document. Have you tried it? Have you found challenges with it? Do you have suggestions about the document? We'd like to update the document once we hear from people about how they've tried to deploy it. Finally, near the top of the page, the arrow points to a link which takes us to this slide, this page, where we've posted a bunch of materials we've tried to develop to help you deploy. So a bunch of resources. And you'll see there's a few there we haven't finished yet. But we've got a bunch of them up there that hopefully will be useful to you. We encourage you to download those, use them, and again, give us feedback about how those work. So we don't have another SPaT Challenge webinar specifically scheduled yet. We encourage you to stay tuned to the SPaT Challenge page and pay attention to the materials you get from the National Operations Center of Excellence, where they advertise these, and there's a way on the website where you can sign up for newsletters from them if you're not getting them, so that you can be aware of the next one of these. As you listen to this one today and have an opportunity in the chat box or want to reach out to us individually outside of this webinar, we would like to hear from you what kinds of topics you would like covered in subsequent webinars. Would you like us to revisit some old topics, maybe some updated information on some things we've already talked about? Would you like to see more deployments? Would you like to look forward to other kinds of things? We'd like to hear that from you. Since you're interested in logging in and participating with us, we'd like to know what you're looking for. So please feel free to share that information with us. As I indicated in the beginning, the basis of the SPaT Challenge is really to deploy DSRC units on the roadside and broadcast a SPaT and a map message. That's the essence of the challenge. And when you undertake the challenge, that's really what's kind of required of you as an intent. But as I indicated, a lot of people are looking at what's next. What else can I do? What can I do beyond this? And so here are some things we've talked about and some ideas for how you might move forward. Broadcasting a security certificate. Ultimately, we're going to need to secure all of our messages. And commercial security credential management systems or security certificates are now available to us. They weren't a little while back, but they are now. And so there's a way to do that. Broadcast a GPS correction message to make sure that the GPS data you're sending out is even a little more accurate. And there are ways to do that, and we've had some webinars about that as well. Installing OBUs in some vehicles and learning to communicate between them, the essence of the Connected Fleet Challenge. And we've talked about that. And as I've indicated, a lot of folks have moved forward and tried to implement some V2I applications. After having done roadside and some onboard units. They're looking at some applications and playing with some of those ideas. And a lot of you are interested in those things. So today, what we really wanted to focus on are connected vehicle applications. We want to look at several locations, talk to people who have developed some of these, and learn from those. So we'll start today, and remember to submit your comments and questions in the chat box up here. We'll start today going to Texas with the Texas DOT, and we'll hear from Jiangming Ma and Steve Chu of the Texas DOT as they talk about their SPaT challenge work and some of the applications they've been developing. So with that, I'll turn it over to Jiangming and Steve.
Thank you, Blaine. This is Jiangming Ma with Texas Department of Transportation. Today with me, Steve Chu, my colleague from TxDOT Houston District. We're going to discuss some of the SPaT challenge activities that we're doing in the state of Texas. First of all, I want to thank Blaine for your leadership in promoting this SPaT challenge. I want to also thank AASHTO, ITSA American ITE for hosting this webinar series. And we have learned a lot from the webinar series. Really appreciate it. I think without further ado, I'm just wanted to discuss. This SPaT challenge and emerging vehicle technology, they're changing every day. As we are speaking, I know there's a point here. I'm not sure if you can. No, you may not. There's a pin on Texas map. So on Austin. So basically, as Blaine just mentioned, there are a lot of states that have been doing this. Texas, we are not. We're also doing a lot of good things, but we're not good at putting pins on a map. So this is what we are doing. I'm just going to give you a close look at the map here. So basically, besides Austin deployment, we also have a few other ongoing deployments like San Antonio, Houston, Fort Worth, and Frisco. So just a little bit. The TxDOT Houston district, they deployed some SPaT challenge equipment at signalized intersections on SM Farmer to Market Road 1960. So which my colleague Steve will be presenting. And besides the TxDOT Fort Worth districts, they're looking and planning some deployment over there. And State of Austin, I believe they're working with CVRA grant, deploying some of the SPaT equipment over there on the Grove Boulevard, as well as Cesar Chavez, and the City of Frisco and the City of San Antonio. They also deploying some of this equipment, and especially the City of San Antonio on the Fredericksburg Road. It's a big transit route, so they probably work with the transit agencies like Utah DOT, trying to implement some of the transit signal priority and other applications. And I think that's just a quick overview. Next, my colleague Steve Chu will talk about the Houston deployment. Steve?
Thanks. Thanks, Jimmy. And good afternoon to everybody, I guess. And what we try to do here in Houston is, my objective in Houston is that we try to, to a SPaT challenge, what does the driver get benefit out of the whole entire thing? So my approach is more toward how do I benefit day-to-day average driver? What can they get out of the system? And so the reason being because we got a lot of drivers tend like to tax while it's at the signalized intersection. So what happens is that when they do that, you tend to get a lot of issues. The drivers not react to a signal fast enough, and they get like a gap out, any kind of issue with at the intersection level. So we try to see, okay, maybe this will improve let the driver be aware of the signal rate to go change, and then to refocus back to a signal instead of looking down to their cell phone or any kind of devices they're not supposed to pay attention to. So basically, we just follow the understanding of the SPaT. So basically, we're going to send out the signal information to the from the intersection, and then we're going to hopefully in the driver's side they'll be able to see that information from the intersection, the signal information. So that's our basic goal is. So what we did is we had to update our controllers, and we had to update our controller to be able to transmit a SPaT message, and then after that we get a roadside unit. What we did our project is that we have vendors design the system for us instead of us designing our own system. It's easier to have a vendor or manufacturer behind the product, and when you have some sort of technical issue, they can help us resolve the issue a little faster. So that's why we more focus on a system-wise, complete system, where a vendor designs a system for us and we just deploy it and testing the limits of it. So basically, we don't have a controller and send out to the roadside unit. It's basically just a DSRC radio, and then we install OBU in our test vehicle, and then hopefully we should be able to see the information from the intersection from our vehicle. So this is by one of our controller manufacturers, by Intel. And so this is their schematic design. So basically they have a controller. We replace our controller, put in their controller, so they can send out the correct map data with the DSR through a DSRC. And on the other side of it, their OBU is not just simple OBU. They do all the data processing inside vehicle. So basically, they have all the Raspberry Pi to do the data processing, and also some sort of network switch in there to connect it to different type of device in the vehicle. Everything all Ethernet based. So that's how this Intel company, Intel control manufacturer designed their system for the connected vehicle system. And we didn't have a Raspberry Pi, so they can transmit the information to a tablet. And from that, we get to see the SPaT messaging through the tablet, through the app they created. So this is their system. But this system only DSRC only, doesn't do anything else, only 100% DSRC equipment. And this one is designed by cooperation between the Applied Info and Kauai control manufacturer. So on this design, we start thinking, okay, there will be a transitional period between connected vehicle and non-connected vehicle. Then how do we address the vehicle that is not connected? So this is the architecture for the transition period. So if you look at the diagram, from the intersection control side of it, the SPaT messaging was sent through their unique, we call it RSU processor. From that, the SPaT messaging got sent out in two directions. One direction sent straight to a DSRC radio. The other part sent straight to a cellular network, which is hosted by a third-party network. So any information sent to a DSRC radio will broadcast out straight to the OBU. If your vehicle has OBU, onboard OBU, you'll take that information and then transmit that information to an app. And the other part, DSRC, if your vehicle does not have any kind of OBU device, it'll transmit the power SPaT messaging will send to the cloud, a third-party cloud, and you have to download their apps, which is called Travel Safely apps, and their apps will communicate to their server, and that SPaT messaging can also send to your cellular device, either to your cell phone or your tablet. So that will give you, to me, that's more like a transition solution right now, because if your vehicle does not equip with the connected vehicle technology, and then that means driver cannot get a benefit of the technology, the system. So we try to figure out how to get everybody covered, and everybody can use the information we try to provide them. And of course, there's a latency issue in there, but that's up to the vendor for them to resolve that latency issue. So that's this part of the design. And so what we did out in the field, basically we just installed our vendor equipment. We just installed DSRC radio, and then we swap our controller or update our controller, make sure it's capable of sending out the SPaT message or add a different module to make it work. And then we install a couple of OBU in our own vehicle, and then we just do a test run and collect all different data on it. And this is one of the vendors' equipment looks like. So basically, we swap out the controller. It's an Intel controller. So we swap out the controller, and then after that, we install the DSRC radio. So for this system, it goes straight from the controller to the radio, and from there, it broadcasts the SPaT messaging. And then we have a test truck, and that truck mounting outside, that is a OBU that's receiving it. And then the other picture showing what's equipment inside. So it's not very, to me, it's not very clean design, but it does the job. So each vendor has different way design their own equipment. And I only have a picture for Intel. I did not include a picture for the Econ system. Maybe on next time I'll include a visual picture for that.
Okay, thank you, Steve. I guess this is our quick overview of what Houston District has been doing in the SPaT challenge area. As you can see, we have a lot of other places that are also undertaking this challenge right now. Maybe in the future we will get more update. But one of the challenges that we're facing is Texas has a lot of diamond interchanges. So right now from what I have seen, a lot of these SPaT challenge places, they're like a regular 4-leg intersections, but for this diamond interchange, they're like literally like two closely spaced intersections, signalized intersections. So how we're going to develop like messages and other things. That's something that we're still working on, trying to figure out. And I think next from this, from this deployment, I think the purpose we can have our people, technicians working with this technology, trying to get familiar with and be prepared for the large scale deployment. How we're going to leverage the connectivity that's enabled between vehicles and infrastructure. Then we can improve our transportation, safety, mobility, and efficiency. So with that, I think our next speaker is Cameron Mott from Southwest Research Institute. Cameron, it's yours.
Thank you very much, Taiming and Steve. Sure appreciate that. As Taiming mentioned, I'm Cameron Mott from SWRI, and I'll be presenting on our efforts to enable large-scale SPaT challenge deployments, specifically focusing on our project with GDOT in Atlanta, Georgia. So I'll be covering the following topics. I'm going to get into a little bit of background and give a bit of a shout out to Alan, who presented on a previous SPaT webinar on October 23rd on many of the same components that I'm going to discuss today. I'll go into a little bit more detail on some things and a little less detail on others. So I do highly recommend that SPaT webinar that's online and recorded for anybody to get some background if they're interested in additional items. Then I'm going to discuss some of the in-vehicle applications, and I'll provide some additional insight about our testing and validation efforts and our research into large-scale remote device management. I'm going to wrap it all up by bringing in some of the other projects where there are some synergies and some connections to this effort. And I do ask, I'm told that questions should be saved until the end of all of the presentations. But again, we welcome people to put in questions to the chat box on the right-hand side. All right, so let's get a little bit of context. We all are familiar with the SPaT Challenge website. highlighting some of the planned and some of the operational deployments across the nation. Many of us have a pin that's particularly of interest to us there. This one I'll be discussing will be the deployment in Atlanta, Georgia. This is under the direction of Alan Davis at GDOT, and Atkins and SWRI are working for GDOT. And I'll be covering a little bit more about what we're doing specifically for that. So we'll take a closer look at those activities in Atlanta to enable the deployment of SPaT and MAP at 54 signalized intersections, all in the heart of Atlanta, Georgia. It's a beautiful place. I highly recommend it. Just don't get lost on Peachtree Avenue. All right. So this one is the deployment across State Route 141. It's approximately 40 intersections and all along this particular corridor. Additionally, for those initial 54 intersections, there are also an additional 15 intersections all along State Route 8. Some of you may be familiar with State Route 8 from some of the demonstrations where we were demonstrating some of the SPaT and MAP deployment efforts as well. All right, so this deployment that I've been discussing so far is the deployment for the existing 54 signalized intersections. But coming up next, we'll be incorporating an additional 250 intersections and multiple RSU vendors. And I think that this is a real defining component to the vision for this particular project. It is large in scale, and those are some of the challenges that we get to tackle in terms of being able to solve this particular deployment for GDOT. So what does it take in each of those intersections? As depicted here, each of the intersections are including lane level maps with all the lanes as well as the connections. Many of you are probably very familiar with this. It's probably near and dear to your heart, or maybe a little of a bit of a frustration. But this is an interpretation of how the lanes are shown as received by our OBUs. So our application is receiving all of the map messages and getting all of the geometries out of that map message and then plotting it in a KML file in order to be visually represented, and we can utilize this for a number of verification purposes, as I will show in just a moment. I'm going to discuss a little bit about our in-vehicle applications. So these are our screens from our engineering user interface. This first application is the phase time remaining. And as I mentioned, the information for much of this has been covered already in a previous webinar. I'm going to talk through a bit of it, and you folks can keep an eye out for something that's of particular interest for you. So the phase time remaining gives the countdown for the number of seconds until the light changes to the next phase. It also indicates what that next phase will be by showing the countdown in the light for the next phase. So in this case, the next phase will be green in 4 seconds. And for this one, the next phase will be yellow in 17 seconds. This is just one example. We also have quite a bit of debug information that's available to us because, you know, we're engineers and we want to see a little bit more information. But it does allow us to depict the things that are important for travelers that are on the road right there at that intersection. And in this example, we can also display multiple movement phases for any of the relevant signals ahead of the vehicle. In this case, this is a left or straight lane, and we depict both because we don't have information about where the vehicle is intending to go. We just have information about where the vehicle is currently and an approximation of what we would expect the driver would need. The second application is the green speed application, and it helps drivers to make an informed decision regarding whether or not they will make it through the intersection during the current phase at their current speed. For this particular screen, if this were the scenario in front of this vehicle, I wouldn't really recommend that they speed through the intersection in order to make it. You can see here the depiction of the time remaining in seconds of 3 seconds, and an indication of the target speed and the current speed. So this vehicle right now is traveling at 7 miles an hour, and in order to make it in the next 3 seconds, that 100 feet to the intersection, they'd need to speed up to 23 miles an hour. Now, given that's the next phase, and they may want to go through it on a yellow, but it appears that this vehicle is slowing down already, and it's unlikely given this information. But we are presenting it to drivers and, of course, allowing them to make their own much more informed decisions. The third application is a red light violation warning application that gives an indication to the driver if the vehicle is in danger of being in the intersection during a red, or in this case during an orange, yellow light rather, and allows them to have information about what's going on with the signal light. So in order to enable all of these, I'm going to move into a little bit more of our testing and validation efforts. This testing and validation, we are involved at all portions of the process, and having that kind of involvement can really make a large difference in being able to smooth things over. So for example, we can provide continuous improvement in terms of map interpretation and map encoding. And as one of those examples, we've been able to implement a number of verification algorithms that help to detect inconsistencies in the defined maps. Here are some of those errors for 3 of the intersections that have been detected by one of our algorithms. These intersections are all properly formatted, but the interpretation of the information is in some ways flawed. These 3 intersections show a connection to a lane which is not defined, and that is an indication that someone has put something into the map that maybe didn't complete all of the steps, or there was something that was just incorrect in terms of the lane numbers, for example. But this kind of an algorithm can detect those kinds of errors and then print out a flag or print out a log in order for us to go back and improve the map generation process. And then, of course, deploy them back out to the intersections and note that the errors are able to go away in that case. We also have the capability to do visual verification of the encoding of map data. Here's an example of a few of these, and if you're very familiar with them, you may be able to take a look at this and spot some of the issues that exist within these particular intersections. So on the top right intersection, as just one example, there are lanes that are defined as if they are egress, but they are supposed to be indicated as ingress lanes. In our tool, in KML, we found that it's very handy to be able to color code the type of each of the lanes so that you can visually just take a glance at it and see that those lanes have been defined going out from the intersection, but in reality, those lanes should be coming in. On the picture on the left, one of the ingress lanes connects to an ingress lane from the opposite direction instead of to an egress. That's a little bit more difficult to spot, but if you note the connects to, they're extraordinarily long in those cases. And we may even be able to, in the longer term, put in algorithmic checks for things like this. But for the moment, being able to look at the maps and seeing them as we do our verification, it kind of just, we see it and it pops out to us after being familiar with it. And by being able to view these interpretations of the maps, we can then improve their encoding and correct it for future deployment efforts. It turns out that many of these intersections are also very complex, both in their intersection geometry and their signal timing. And because we've been involved at all levels, we can provide some guidance on some ways to properly encode and interpret these more complex intersections. Some of these intersection issues are being addressed for the first time, at least that we're aware of. We hope to be able to provide guidance on what we've learned or even feedback to some of the standards committees regarding good practices. We've also run into that restriction on message size. I'm sure many of you are familiar with this. And we've come up with some possible options on how to be able to utilize some of the existing capabilities to reduce them, both in terms of reducing complexity, as well as being able to leverage some of the built-in mechanisms, such as remote intersection definitions. So in this case, this particular intersection is defined without egresses on the westbound lanes, and instead those westbound lanes are defined in another intersection as ingress, and the connects to can point to those remote intersections and show up as a connects to the ingress for the next intersection. In addition, one of the highlights from our project is our ability to forward messages from the field back to our lab. It allows us to monitor and verify some of those SPaT and MAP messages in real time from each of the signal controllers. This is a representation of the phase and time remaining for each of the phases based on the reports from the signal controllers. As you can note, there are still some improvements that are needed from the signal controllers. I really don't think the minimum time remaining for these particular signals is 0, but we at least can see the current status of that particular lane, and it gives us an indication of what we would expect to see presented to drivers at that particular intersection. We also envision that BSMs can be forwarded from the field, providing additional insight and some data analysis capabilities. All right, so taking a look at the big picture, right now we're talking 54 intersections. We're going to be talking 250 intersections. We need a good way to do large-scale remote management of the RSUs that are enabling these kinds of SPaT deployments. And if we're going to be supporting 250, and even the following large-scale vision for GDOT includes 1,700 RSUs, even of multiple vendors, we're going to need some way to be able to manage them in bulk effectively. We need to be able to minimize the amount of time that an operator takes to interact with one of the RSUs or many of the RSUs. And we envision that this kind of improvement can occur through a screen like the one you see here, something that would be an RSU management screen with a program that can allow an operator to interact with those RSUs that are deployed in the field. They can see kind of at a glance the status of the various equipment, whether or not it's up and active, or in the cases where there's a red row, something that is not responding properly and may need some TLC or even a field visit. We also have the capability to do things like remote rebooting or even firmware updates that can be executed from this application. The example I'm showing here is a verification of the single device remote firmware update as we work on developing larger batch updates of multiple devices while being able to minimize that operator interaction that I was referring to. We think this is a mechanism that we can move forward with to allow for large-scale support for GDOT's remaining vision, and that this can be a valuable effort for others that are considering the possibility of doing large-scale deployments. All right, I'm going to talk a little bit about some of the project synergies. So I'm always excited when I see areas where one project's efforts benefit another project and vice versa. Here are a few of them that we're aware of that we can bring up during the call. One of those is the next car effort, where we're focusing on being able to do powertrain optimization based on SPaT and also with MAP. So by utilizing that SPaT and MAP data, the vehicle's powertrain can be prepared for the upcoming intersection and in effect using less energy. We are utilizing a simulation environment called Transmodeler and some ground truth data that we've collected from a corridor in Dallas to be able to realize this challenge. We've got about a year and a half left. We're expecting a 20% improvement on top of the already incredible efficiency of the 54 mile per gallon hybrid that we're targeting for this effort. Another one of the projects that has some synergy with this effort is the Texas Connected Freight Corridor, and some of the direct efforts that'll tie in well with this. The Texas Connected Freight Corridor, as Jianming will be able to fill in quite well on all of the efforts involved with that. We're focusing on a Texas triangle between many of the major Texas cities, especially those that have quite a bit of freight travel. that goes between them. There are some direct efforts, including the SPaT corridor and truck signal prioritization, that can benefit from the efforts regarding the SPaT and map deployments that we've been doing, as well as some of the enabling applications such as Q-warn, wrong way driving detection, and border wait times that can leverage some of the data that we would be getting from the field from things like BSMs or travel time predictions. So those are just a few of the projects that also have synergy with this existing project, and being able to provide kind of a holistic improvement of all of the efforts involved. So in conclusion, we've gone through the background of GDOT's vision with 250 to even 1,700 intersections and multiple RSUs. I went over the three in-vehicle applications that are enabled through this effort, some of the testing and validation efforts that have been able to provide for this kind of capability, our vision for the large-scale remote device management and being able to handle with minimal operator interaction this large number of RSUs, and some additional project synergies. I appreciate the opportunity to present this, and I'm going to open it up to Mike Mollenhauer, who will be presenting on his efforts with the SPaT Challenge. Mike?
Thank you very much, Cameron. Appreciate that. Don't see my slides coming up. There we go. Okay, so what I'm a little bit different in terms of the content of my presentation today. We'll talk a little bit about some of the connected vehicle and work zone activity we have going on up in Northern Virginia. We do have a kind of a SPaT component to our connected corridor, but that will not necessarily be the focus of this presentation. So if you have any questions about any of our SPaT related efforts, I can address those offline or through some other means. So when I mentioned the connected corridor, in partnership with VDOT, we have developed what's called the Virginia Connected Corridors, and really there are two components to that. There's the Smart Road, which is down kind of in our backyard down in Blacksburg. It's a test track facility. We have 8 RSUs down there and a full-up test track where we can evaluate the safety and the performance of applications before they're migrated to the Northern Virginia test bed. Up in Northern Virginia, we have about 50 RSUs deployed just outside the Beltway, kind of in Northern Virginia, kind of southwest of DC. This is a little bit different map of that Northern Virginia test bed. The lighter color pins that you see are on intersections where there are arterials where we have a connection into the traffic signal cabinet. The rest of them are on freeways, and we've done the deployment in this way to support the testing and the development of a variety of different applications, both on arterials for things like SPaT and map enabled applications, and also on freeways for things like queue detection and merge support and things like that. Okay, so behind all that equipment that's been deployed on the road, all those DSRC radios, we also have what we call the VCC Cloud. This is a homegrown server-based application that functions as an application processing space. It's a data hub, so all the messages from the system, including BSMs coming in from all of those deployed RSUs, and from a public cellular API also come into the cloud. So they kind of all get brought into the same common spot, and they get archived, or they can also be processed in real time if there are applications that require BSMs from multiple locations. To support the development and, I guess, the creation and deployment of traveler information messages, we also tap into VDOT's data sharing sites. So this is the same data sharing system that powers their 511 system. So we take all the traffic incidents, work zone definitions, active traffic management data, variable dynamic message signs. We pull all those into our cloud, turn them into the appropriate messaging standard. In this case, that's typically a traveler information message, and then we broadcast them back out either through the cellular interface or through the roadside DSRC units as well. We have a couple of other applications that we tap into. One is called the VCC Monitor. I'll show you a different picture of that here in just a little bit, but that's really a situation awareness tool that allows us to understand what's happening in the environment. That includes the uptime and the reliability of the deployed equipment, but also when we have actors that are interoperating within the system, we can kind of tell where they are. Largely that's for research support as opposed to any kind of actual operation. I mean, because of the anonymity issues, we wouldn't necessarily want to be able to track those individuals interoperating over a period of time. So just keep that in mind, that it's really about doing the development and validation efforts here more so than long-term operation. We have a connection to a public data sharing portal called smarterroads.org. That is a VDOT data sharing site, so we push SPaT and map messages and now traveler information messages out through that website, and they can be received pretty much by any third-party developer who wants to get them in near real time. Also connected to the cloud, we have our roadside DSRC units, and on those 30 intersections where we're connected to the signal controllers, we are pulling in to the roadside unit timing data from the controller so that we can generate the SPaT messages locally. And up in that Northern Virginia region, VDOT operates the ATS D4 firmware on the intersections that we're engaged with. They have about 1,400 that are deployed in that entire environment. We're tapping into about 30 of them. And so we had to work with ATS, or Advanced Traffic Solutions, to develop a custom interface to push that data from the controller to the RSU so that we could compute and create and format and broadcast the SPaT messages coming out of that unit. It was infeasible for us to be able to pull in a different, maybe a SPaT-enabled controller and swap it in, just because of the way that they control and manage that environment. We had to work with what was there in place and then add on to it. So that has taken a bit of work to get that interface together and to make sure that we've debugged and validated all the data that's coming through from that. So we also have occasionally had fleets of vehicles, and when I say occasionally, they kind of come and go as we have other research studies operating in the area. So we pull in, when we say have like 50 to 100 vehicles, we can deploy them with onboard units in place, and they will interact with the environment. And just depending upon the goal of the, I guess, the parallel research study that's going on, we may or may not enable applications to provide, I guess, information back to the driver based on what they're receiving through the roadside units. So again, we, from time to time, we have a lot of vehicles up there to almost no vehicles. It just depends upon what's happening in the research space. Work zones are of a particular interest to VDOT, work zone safety in particular. And so we've been developing a variety of different applications to help provide higher quality, higher resolution, and more timely work zone data. And that's largely what I'm going to be talking about throughout the rest of the presentation. So some of our recent activity I'll just cover before I move on into the work zone side of things. We have ongoing SPaT and map validation. I mentioned before, we're really doing this to assess our readiness to deploy the applications that we'd like to run underneath or with that data. And we've gone through, I guess, one iteration already of collecting a variety of different SPaT and map data points out there in the field, and we're doing things like measuring latency and accuracy. Of course, because this is new, we have found a few incidents from time to time, and we are in the process of correcting a few of those. We have also gone through the SPaT verification document that Blaine alluded to before, and we've made some other updates in terms of our interpretation of how map files should be deployed. And so all those updates and changes are in play right now and should be deployed here by the end of the first quarter, and we'll do another round of validation. We hope to publish those results off that second round, and we will look for a good opportunity to do that. And if there is an opportunity to come back and present to this group, then we would do it. We'd be happy to do it at that time. We've also deployed the GPS RTK correction system. So within that northern region operations, there was not an RTK system or a base station that we could tap into for public use. So we went ahead and deployed our own base station in the area, and we are taking in those corrections. Now they come into, the actual base station itself is mounted on a traffic cabinet at an intersection, and we are taking that data into the cloud and being able to broadcast it. And most of the region that we're operating in up there can take those corrections without a whole lot of loss of, I guess, accuracy or correction effectiveness, just based on distance, because the further away you are from that base station, the less effective their correction is. But regardless, we are currently supporting the broadcast of RTCM messages from that area. We have done some accuracy assessments, some field observations, and collecting data to understand, with a corrected GPS versus a non-corrected GPS, what are the differences in accuracy. We've done a first round of data collection, and we've shared those results with VDOT, but we have not yet published anything. We hope to, again, have a second paper coming out on that at the end of the first quarter that will discuss what accuracy we're actually seeing and what the benefits are of having that RTCM broadcast in place. Then on the work zone side of things, which is kind of more what I'm here to talk about, we're essentially trying to create applications and a flow of data that is more accurate, more timely, and a little bit more precision that we normally get from infrastructure data sources such as the 511 system. And we also want to look at some of the dynamic parts of that as well. So like, can we create a smart vest for workers to wear that will localize them and give their position updates on a regular basis? And can we also create applications for safety service patrol folks so that they can understand where they are, so we can understand where they are and what kinds of incidents they're dealing with on the side of the road. I just had a connection interruption there. It's updating. Okay, there we go. Okay, so again, the reason or the purpose that VDOT has us looking into many of these temporary road configuration changes is because they're a bit of a challenge for connected and automated vehicles, and we're trying to prepare the roadway environment for them to use in the future. And so if you look at things like work zones, traffic incidents, unusual or unplanned events, I think many of the AV developers are trying to build their systems to be able to detect and respond to those things automatically, but we believe it will be much more effective if we can come out with a more of a detailed data solution that is standardized, that everybody can act on, or all those automated and connected vehicles can act on, that is maybe, I guess, a little more timely and a little bit more effective and consistent across the different receivers. So, we also acknowledge that some of our infrastructure owner-operator source data could be a little bit more accurate and timely and perhaps detailed. For example, on a work zone up in Northern Virginia, we typically get, from mile marker X to mile marker Y, and, perhaps they indicate what kind of activity is occurring, and maybe if there's 1 or 2 lanes closed or a shoulder closed. But we would like to have a lot more information about things like where tapers begin and end, and other hazard sorts of implications that come with those kinds of zones, I guess. And we also, essentially just want to be able to exercise these systems and be able to deploy them statewide, so that when we have corridors that I guess are developed for both connected and automated vehicles, that we're ready to pull the trigger on pushing that data. I mentioned before some of the additional connected and automated vehicle data elements that we're interested in. I apologize, looks like some of the text wrapped on a couple of these slides. Essentially, all throughout the work zone, from approach to transition to where the activities areas are, we're looking for a little bit more detail. So, typically that for us, that's going to be lat-long geographic position, a general description of what's going on, when and where lanes closed are closed, and when and where the activity areas are, so we understand the risks associated when they're occupied, when workers might be a little bit closer to the roadway, and we might want to be a little more vigilant as to when collisions or conflicts may occur. Barrier types, other types of hazards, things like steel plates, sometimes we have rumble strips, sometimes we have things like reduced visibility. All those things we would like to enunciate through the data flow to make sure that the receivers are understanding what the situation is at all times. Things like reduced speed limits, they're not always necessarily consistent across the different types of work zones, and so we'd like to be able to enunciate those as well. I know that there are systems out there that can read signs, but it's, again, more effective if we can help cross-validate that with a good data solution underlying that information. Specifically looking at some of the work zone components and products that we are developing for VDOT. I mentioned before we had that VCC cloud. That's what kind of sits in the middle of everything. We've got the VCC monitor, which shows where messages are posted in terms of their geolocation and where they're relevant. It also gives us the status of all the other equipment and all the other actors in the system. We've got this VCC mobile application, which is kind of an Android-based cell phone application that can be used by an end user driving through the environment. And if they come across the geolocation for any of these messages or areas that have been posted, it'll enunciate the message to them, so it'll read it aloud to them so that they get that information as they're driving through. And that's really, in an era when there aren't a whole lot of OBUs and deployed connected vehicle equipment available on the roads, this mobile application has kind of given us the ability to do test and demonstration activities and to validate some of our efforts so that we receive the same messages that hopefully OBUs will receive in the future through integrated systems in the vehicles. We also are working on a worker and safety service patrol application, the connected worker vest that I mentioned before, and the work zone builder tool, which allows us to get a good detailed definition of that work zone prior to even when it's set up on the side of the road. Just a little more detail about VCC Mobile. I mentioned before, it can be cellular or DSRC enabled. So if you have this phone device in the vehicle that already has an OBU and you're within range of an RSU and receiving data from it, it'll take the data through that, I guess, that pathway. If you're outside of a DSRC range, it'll use traditional 3G, 4G cellular to connect up to our cloud environment and then pull all the same messages down through that. So, depending on where you are and whether or not you have even basic cellular connectivity, you can use this application statewide to get all the messages that VDOT is putting out. The VCC monitor, I mentioned before, it kind of gives us a real-time SPaT status display. It shows us the message flows and what the volumes are on the environment at any given time. And we've actually got it instrumented to show us where some of the bottlenecks are now so that we can look at stress testing. If there are messages, lots of messages flowing from one area to another, we can understand what that volume is. So this really gives us a good idea of what the performance of the system is, but also what's happening on the environment at any given time. So VDOT, in order to get us, I guess, or enable a really positive flow of high quality data to this system, VDOT has contracted us to build what's called a work zone builder application. And the idea is that, rather than lumping a new task onto these folks who are designing the work zones, can we give them an application to make their job a little bit easier, to actually help them facilitate the design of the work zones, and then use that as the supporting, I guess, environment where you produced that detailed data that we'd love to see, in the work zone definitions. And so it's really designed for contractors to use to sit down and tap out or to create a work zone based on the guidelines and the MUTCD and work area protection manuals for the state, and then how do they flow that data into the system, and then how do they use it to maximum benefit. And that's where we have the design, management, and field modes. So the design mode itself, again, you use a map, you find the location of where you're planning to do your work, you tap out an activity area, and then you select a template you want to apply. So for example, if I want a TTC 4.1, if I'm going to close down a shoulder, I would apply it to a certain area. The application goes out to the work area protection manual and pulls out all the links that are desired for things like buffers, where all the sign placements have to be, whether or not an aero board or a shadow vehicle or a TMA needs to be used. The types of barriers that are recommended based on the time of day and the type of work zone it is, and then the links and positioning of the, I guess, the tapers, and so how many, I guess, the dividing devices need to be added to the inventory. And it essentially creates that entire map and puts it into the map. I'm sorry, it creates that entire definition of the work zone and puts it onto the map. And then the end user has the ability then to adjust where those features are based on local conditions. So for example, if it puts a sign in an area where maybe there's a driveway, you need to adjust it one direction or another, you can do that in real time on this definition. And then it kind of keeps everything else in sync and updated such that your, hopefully the end definition of this is a work zone that can, a work zone definition that can be validated and approved by VDOT after it's submitted. And so this gives us the ability to also create an inventory so that the contractor, when they go out to set up, I guess, the work zone, they can understand what they need to load on the truck, and so they can use it to facilitate that part of the process as well, making that part of the job easier. Oftentimes there are individual features you need to add that aren't in the template, so we have a feature palette that allows you to pull down individual items like additional signage, maybe rumble strips, things that aren't part of the normal template that you want to add to that work zone. Then you can go out and create those as well and put them onto the design so that they can be reviewed by a VDOT work zone inspector. The management mode is then what you use to kind of set up the review, revision, and approval process. So once I build this work zone, I say validate and submit. The validation process will go through and make sure that you're at least adhering to the minimum distances for things like buffers and barrier types and things like that. It then goes to a VDOT inspector who reviews that definition online, and they either approve or don't approve it, and they give you some feedback and then send it back for revision. That's always a possibility. From that then, you update the statuses and dates as to when it will be deployed, and you can use the tablet to keep that in real time. And we're building in also a workflow for those contractors so that, if they have a work zone that is supposed to be active on a particular day, we can give them a notification when they open up the application to say, hey, are you really there? And what will be your hours of operation for the day? So the idea is here to really kind of keep that data as up to date as possible. We are then integrated with other VDOT systems, and I say loosely integrated, meaning we output data from our system that is easy to enter into the other systems. We don't do a direct integration just yet. VDOT would like us to exercise the system a little bit more and gain more confidence with it. sometime in the future, we hope to be more tightly integrated where we're directly injecting data into things like the VA traffic and the LCAMs, which is their lane management system, sometime in the future. The field mode then is another kind of mode for the device. With its GPS, you can take it out into the field and use it to help localize where you want to set up the work zone, including where sign placement should be, where the beginning and end of the taper is, all those kinds of features. So as you drive through, it'll give you a countdown of distance to where that feature should be located, and you can use it to measure distances. You can use it to position individual types of features of the work zone itself. So it's a really, hopefully, easy way to, number one, go out and deploy what you've designed, but number two, if you get out in the field and see that you need to make an adjustment, it makes it easy to say, hey, I'm in this particular location, I want to move this sign to this location. You can do the update in the field and then also be able to push that into the VDOT system quite rapidly. Okay, so moving on to the more dynamic elements of the work zone, the Smart Vest system. This is a cell phone-enabled device. It's got a GPS chip that is RTK corrected in it to give higher positioning accuracy. Battery powered so that you can use it throughout a full shift. Really what you're trying to do is get this onto a worker and make it easy for them to comply with being there and giving their positional information. So from this, we essentially take what is I'll call it a very low rate PSM from a human, and we put it into the system, and we can use that to compute when there's going to be conflicts between passing motorists and that worker on the side of the road, so that you can either give advisory information to the motorist or to the AV that's passing by, or potentially sometime in the future a conflict warning if we get to high enough accuracy and enough low latency so that we can do collision avoidance kinds of messaging. That vest is equipped with LED lights that can flash, a haptic belt so that we can give haptic cues if there's directionality, but also audio on each of the shoulder pads so that you can, in a very loud way, present messages to folks. We're testing all that those types of responses so that we don't startle workers and or annoy them. So there's going to be a bit of a development activity and a test with some real workers, and then we'll tune up, kind of what those responses look like and embed them in the system. But it will be configurable moving forward. So our development on that is we hope to have a batch of those created in Q3 of 2019, and we'll do the final integration in at the end of the year here in 2019 for a full-up demo. I mentioned before the Safety Service Patrol application. Up in Northern Virginia especially, VDOT operates a fleet of Safety Service Patrol vehicles. We decided to create an application at their request that allows them to choose whether they're on duty or not, and then what kinds of activities they're responding to. And this includes things like crashes, picking up debris, fuel assistance for motorists. It essentially puts a real-time message out through either Waze or through that smarterroads.org data sharing site that says where they are, what they're involved in, and so it can be picked up by those third-party users and presented back to the drivers. It's also connected to the TOC, so the TOC gets that real-time update about where they are through an automatic phone application. We're looking at adding additional features like if they need to close a lane temporarily and they have potentially some information about how to navigate through the particular incident, then we can add that in there as well. So we're kind of at the first stages of deployment of this application, and it will also be used for other VDOT roadside workers, whether I'm a work zone inspector or some other role. The application at the top level allows you to choose a role. In this case, it's Safety Service Patrol, but it might be just that you're a roadside observer or something like that, and you can set it up and get those same kinds of notifications. I mentioned that work zone server application. We do run a work zone data manager. This is essentially taking in all the work zone data and turning it into, I guess, reasonable outputs. Right now, that's kind of a travel information message. In the future, we expect that to have more detail, something like a roadside safety message, which has been proposed and is working through its way through some of the standards organizations that can give more detailed information about a localized map message that helps you navigate through that work zone area. We also have it also streams data to local dynamic actors. So if a vehicle is approaching that has our app on it, and we see that we're fairly close to a worker on the side of the road, we'll begin to stream that real-time position so that you get a much better opportunity to provide conflict alerts should a conflict situation arise. And then we're also, again, pushing all that data out to the public portal that can be consumed by third-party application developers should they need to pick that up and want to do a better job of telling you what's going on the side of the road. All right, so our next steps with this entire environment. So you notice we've got a few different kinds of application pieces and parts that we're developing through projects throughout the first half of the year. Those will all wrap up hopefully by the beginning of the third quarter, and then we'll be able to go out and demonstrate them. And we're anticipating doing more of a putting it all together kind of a demo at the end of the year where we demonstrate all the individual features together, maybe in 1 or 2 work zones, and we hope to have that be a bit more of a public event so that some of you, if you're interested, could come and participate and ride along and see how it all works. Beyond that demonstration, we'll be looking at an end user application and naturalistic driving study evaluation where we put cameras and other sensors on board the vehicles and then understand how the individuals are reacting to these messages. So are we adding distraction, or are the drivers reacting as we think they would given the information, or are they doing something different? And so we intend to study that for probably the 12-month period during the year 2020 and beyond. So that's what I had, I guess, to explain to you today. Are there any questions, or I guess maybe I'll toss it back to you, Adam, if you want to perhaps moderate if there are questions from the participants.
Mike, thank you so much for a fantastic presentation. Thanks to all of our presenters. Yes, for those with questions who haven't typed them in yet, please feel free to do so in that question discussion pod there on the right-hand side of your screen. Mike, well, since your presentation is still up, a couple questions for you. It looks like that came in around the smart vest system and the work zone. So the first one there is would the smart vest system be used to notify the vehicles within the work zone of the precise worker position? And then somewhat related, is every time someone moves a barrel or a sign, what does the map get updated? How does that process work?
Yeah, so with respect to the vest itself, I mean, we're looking at what can be done there. So if you have, a variety of workers on the side of the road in a particular activity area, we of course don't want to put out an individual message for each of them. So our work zone server application takes in all their locations and tries to generalize it down to saying, hey, there are multiple workers on the side of the road in a certain distance. So at the top level, there's kind of an advisory message, just letting you know that, hey, people are there, and it's, the region that they're working in is some X number of feet ahead, 500 feet, 250 feet, whatever. And then occasionally, or what we have tried to work on are looking at developing various threat algorithms which indicate, okay, here's the type of barrier that's being used in this area, here's the active lane of traffic, here's the location of the worker, what is the probability or the likelihood that they're going to make their way into the roadway? And then based on their current movement and their likelihood of getting out in the roadway, we may or may not provide I guess a collision imminent type of a warning. That is all very much under test and evaluation. We think that there are many challenges there, but that is kind of the end goal. It would be really nice if we can get there. It all depends upon latency. It depends upon the accuracy of the algorithms that we can develop as to whether or not that's going to be a useful set of info. To answer the question about when, go ahead.
Oh, no, please go ahead.
To answer the question about the barrels and the signs, ideally, that whoever is out there managing the work zone would be able to update the location of that sign, essentially bringing it up and saying, snap to my current position. Again, if it's a contractual requirement that they do that, and that's being managed by VDOT, we'll have to wait and see exactly how that goes. I'm not sure as to what kind of compliance levels we'll get. Part of it depends, I believe, on sort of how well we design the user interface and how easy we make that tablet application to use. I realize that it is likely that we'll probably have I guess a little bit of momentum or inertia to overcome to make sure that the information is often kept up to date. So we'll have to wait and see how that goes as we get into the field trials.
That's great. With the vest, I mean, using it for work zone safety seems like an incredibly important and perfect start to testing that out. Have you or your team thought about other additional uses, around either pedestrians or school children or anything else where this could be implemented?
We've talked about vulnerable road users as a start. Maybe folks that are perhaps a little bit more likely to be in the way of traffic, whether it be folks with disabilities or whatever else, maybe as a first step. I think in the long run, if we can get the cost down and make it cheap and make it easy to use, again, there might be a lot of different types of applications. But certainly, we talked about folks like the Virginia State Police, would they want to try it out when they have, if they have a trooper that's outside of the vehicle? There are, of course, a lot of issues with that about whether or not law enforcement wants to be pinpointed on a theoretical map. Yeah, I think that there are plenty of other applications and spaces that it could be moved into. If we can get a good I guess, definition of data flowing, and we can make it such that, you know, that information is standard and expected by CAVs, then we can start to look at other applications.
Great, thank you. For Cameron, a question came in about GDOT's Green Speed app, and the question is vehicle acceleration from current speed taken into account when providing the target speed to meet green, or does the app assume the vehicle needs to instantaneously be at the target speed?
At the moment, the target speed on there would be an instantaneous speed. We've looked at a couple of different ways to do that and to how to take in different vehicles' acceleration capabilities, but for testing and to minimize variables and to kind of help support just validation of the applications, right now it's just putting up the instantaneous speed.
Thank you. And another question came in there that Cameron answered around RSU management application being under development. So be sure to take a look at that in the box. The other question I had, Cameron, during your presentation was the in-vehicle interfaces, and what are the plans to adapt those for future deployment, either in vehicles or where do you see those going?
So the in-vehicle apps that we have right now, as Cameron mentioned, were predominantly engineering interfaces. I mean, they were primarily designed for proving that the data coming across is valid and that it can be used, and then to demonstrate and get people thinking in the car of what kind of applications could utilize that data, rather than coming up with the clean in-dash OEM, real simple, minimal interface that really hides all of the data in the back end and potential. So, I mean, our intent of those applications is to continue to push out, okay, what other applications could utilize this? You know, the more people that we show it to, the more people that see the different kinds of data, the subtleties behind it, and the timings and the lanes and the intricacies of what goes into the applications, you get additional perspectives and ideas and thoughts on, oh, well, maybe you could take these couple of fields of this piece of the data here and come up with a new application or a new way to present it here. We're trying not to constrain it and come up with that final end OEM interface. So it's really kind of a development, testing, support type application is how we see it.
Great, thank you so much. I wanted to return to the question that was there about RSU management application under development, and let Blaine talk about it from how other agencies are managing RSUs.
Sure, thank you, Adam. We at UDOT currently have about 72 roadside units deployed and operating, and about 35 onboard units, with another 55 roadside units and 47 onboard units to come online here in the next 60 days or so. We have not very effectively managed them centrally. We do have a central interface package where I can dial in and watch the vehicles moving down the corridor and see the information passing back and forth between the vehicles and the roadside infrastructure, and we are pulling all of that data back, but we don't actively watch it. So that tool allows us to get some information about what's working and what's not working, but it's a bit haphazard when we, for instance, find out that for some reason an OBU has bricked up or an RSU has stopped operating correctly, and we don't yet have the capability to download firmware upgrades, for instance. We have to do that in person. So we have enough people involved in the project at various levels that they're keeping an eye on some of those things, but we don't have an efficient central management system. We are about to embark on another contract which will build a tool like that for us. So we know we need something like that. We're headed in that direction. I'm not sure of any other deployment sites that go beyond the kinds of things that we're doing, other than what you heard today that SWRI is doing. I know that Caltrans, for instance, has a portal you can log into and see what's going on live with their RSUs, but I don't know that it, for instance, really is a management tool. So I think that's something that some of us are working on and we all kind of need to go towards.
Great, thank you, Blaine.
Thank you, Blaine. This is Jimin. Just want to add, actually, TextDot. This is Jimin with TextDot. TextDot actually, we through Southwest Research Institute developed a we call the Lone Star connected vehicle module, which has capability of monitoring like RSUs in the field, just like any other field devices. So actually, Lone Star is our ATMS software, Advanced Traffic Management System software, for those of you who are not familiar with. And these two CV module not only monitoring the status of the RSUs and can also send information to the RSUs and update like the data and other things in the RSU. And so we probably will, I mean, right now we haven't connected anything yet, but we're in the process of connecting all our, there's a I-35 Connected Workzone project. We plan to use this Lone Star CV module to monitor and manage the RSUs in the field. Thank you.
Thank you so much. One last chance for folks who might have any questions to go ahead and put them in the chat box there at the left. Quick reminder, the SPaT Challenge map is there, the link to it there on the right-hand side of the screen. We'll get those Texas sites up. And for anybody else who sees any sites that aren't captured on the map, please do email me or follow the email process that's on the website there. And again, as a reminder, this has been recorded and will be available on the NOCO YouTube channel. Doesn't look like any more questions are coming in. Certainly, folks left their contact information on the slides, so please be sure to reach out to them directly if you have any additional questions. I want to again thank Blaine Leonard and the folks from Texas and SWRI and Virginia Tech for these fantastic presentations and updates on the great work that's being done in SPaT and connected vehicles. Thank you again to everybody who joined us today, and we look forward